footprints. We'll do numerical problems based on packing in unit cells. If you remember what we studied, if you take SCC, rank is 1, a relation between A and R is A is equal to 2R. If you remember, in SCC, spheres were touching each other along edge length. Packing fraction was pi by 6. Remember this pi by 6 also. Remember 0.52 also. Both the numbers are important from MCQ perspective. And if you remember for BCC, along body diagonal, you remember body diagonal? Body diagonal, A root 3 was equal to 4R. Rank was 2. And we have to remember both pi root 3 by 8, that was packing fraction, exact value is 0.68. For FCC, along face diagonal, the spheres were touching each other and therefore 4R was equal to A root 2. Rank is 4 and this value also we are supposed to remember pi root 2 by 6. Packing fraction is 0.74. All these numbers have to be remembered and they are important for all the examinations. So, which of them is most efficiently packed? FCC. And which is least packed? Simple cubic crystal. So, least packed, max or most dense packed. So, most efficient packing is for FCC. We go to one numerical where this data is given. Now, what is 361? You should all know its edge length and symbol is A. There are 4 atoms making up unit cell. What does this means? It means rank is 4. You know, when rank is 4, it is called as FCC. It's called as FCC. So, 361 is edge length and 4 atoms, number of atoms making up unit cell is 4. Z value 4 means it is FCC. For FCC, what is the relation between R and A? 4R is equal to A root 2. So, what is the value of R? R value is A root 2, A root 2 divided by 4. Put the value of root 2, 1.414 upon 4. If you are doing it for board exam, use log calculations. Otherwise, for MCQ exam, do an approximation and the value is 127 picometer because the original data was also in picometer. That was a numerical to get a relation between A and R. We go to another numerical. Another numerical that we have is, right, we have a cubic solid made up of 2 elements, P and Q. Now, what are such type of solids which can be made up of 2 elements? They can be ionic solids like NaCl, Al2O3, or they can be alloys. Anyone who is made up of 2 or more elements can be an alloy or can be an ionic solid. Now, they are asking what is the formula of the compound, how to do it. Let the formula of the compound will be Px Qy, where X is a number of P atoms and Y is a number of Q atoms. So, Q are present at the corners. If anything which is present at the corners, you know each corner contributes 1/8. Each corner contributes 1/8 and there are 8 corners. So, number of Q atoms are 1. That means Y value is 1. Y value is 1. 8 is number of 8 corners. 1 by 8 is contribution and therefore, the Y value is 1. We go to next. P. To know more about P, we go to the next. P is present at body center. How many body centers are present? 1. What is the contribution of each body center? Yes, 1. So, number of atoms of P are 1 is number of spheres at body center, contribution is 1. So, total number of P atoms are 1 and X value is 1. If you remember how to write a formula, we remember it was Px Qy and the value of X is 1 and value of Y on the previous slide was 1. Therefore, the formula is PQ. Coming to the next one. Solid has cubic structure in which X atoms make up corners, Y atom makes up cube centers, and oxygen atom makes up edge center. What is the formula of such compound? Again, what type of compound they can be? This type of compound can be ionic compounds. Ionic compound. Can there be ionic compound made up of 3 elements? Yes. Na2SO4, it is made up of 3 elements: sodium, sulfur, and oxygen. Or they can be alloy. So remember, such type of compounds can be ionic compounds or they can be alloy. So coming to the discussion, let the formula of the compound be XaYb and OC, where A stands for number of X atoms, B stands for number of Y atoms, and C stands for number of oxygen atoms. You have to calculate only the value of A, B, and C. Right, X makes up the corners. If you say it makes up the corners, each corner contributes 1/8. So 8 multiplied by 1/8, so it is 1. So from this, what you came to know, the value of A is 1. So we got the value of A. Now we are left with only value of B and C. We go to the next part. Where are Y atoms present? Cube centers. How many cube centers are present? How many cube centers are present? Number of cube centers are 1. And contribution is 1, therefore value of B is 1. Similarly, if you go to oxygen atoms, oxygen atom makes up edge centers. And how many edge centers are present? Edge centers are 12. Each edge center contributes 1/4. So total is 3. So value of C is 3. So formula is XaYb OC. If you put that XyO3, this is what is the formula that you get. If you want to again see, X atoms makes up corners. Corners means 8 multiplied by 1/8, that is 1. So X ka value is 1. Y makes up cube centers. Cube centers are 1. Each contribution 1. Therefore, value is 1. So Y is 1. So X is 1. Y is 1. And oxygen makes up edge center. How many edges are there? 12. Each edge center 1/4. Therefore, 3. So oxygen is 3. Therefore, formula is X1 Y1 O3. So we come to the end of the numericals connected to this part. We will continue with density in the next class.